So this is the third lesson in our unit on moles, and where we are learning about moles and the mole concept and molar mass. What we've already done is we have learned about something called molar mass. By looking up the masses on the periodic table, we can figure out how much to weigh out of an element or a compound and know how many particles it has. So we're going to do the math that supports that, but please know you should have your reference table and a calculator handy to do this work. Okay. So this lesson, we're going to be doing molar conversions, specifically converting between grams and moles of a specific substance. So we've learned that the atomic mass on the periodic table is also called the molar mass. Right? That's a big, big concept. The atomic mass on the periodic table is the same thing as the molar mass. The only difference being when we're talking about the mass of a single atom, we use the unit AMU. When we're talking about the mass of a mole, we are using grams per mole as our unit, but the numbers are the same. It's very convenient. So if 1 mole of methane, which has the formula CH4, weighs 16.0 grams. Okay, now how did I get that? Right? CH4, 1 carbon, which is about 12.0, 4 hydrogens, each at about 1.0, right? That's going to add up and equal to 16.0 grams. We can use that equality of 1 mole equal to 16.0 grams to help us convert between moles and the mass of methane using the dimensional analysis technique that we have previously learned. Okay, so let's say you know that you have half of a mole to 3 sig figs. This is 3 sig figs. And we want to know how heavy that should be. Okay, so we're starting with our number that we were given, right? This is the measurement given, 0.500 moles of methane. And we want to convert that to grams, right? So, so this right here is the given quantity. And this right here is our equality. Now, we wouldn't want to put 1 mole of methane here and 16 grams here because moles times moles won't cancel. So that's why we're going to put 1 mole of CH4 here in the denominator is equal to 16.0 grams of CH4 in the numerator. So moles of CH4 over moles of CH4 are going to cancel. And, right, we shouldn't need a calculator, but we're going to use one anyway. So half of 16 is 8. We want to maintain those significant figures. So this is 8.00 grams of CH4. Please note that this fraction is a perfect equality. And when we say perfect, it does not limit your significant figures. So when you're doing these conversions, then the 3 sig figs that you start with here means that you're going to end up with 3 sig figs in the end. Okay. In other words, you don't let the conversion fraction determine or have any influence on the number of sig figs that you end up with. Okay. So that's the answer to that particular problem. Let's try another one. You have 136 grams of methane. That's your given. And you are being asked to find the number of moles of methane. Okay, so here we have our given quantity. Notice that it is 3 sig figs. And then this is going to be our conversion fraction. And we want the conversion fraction to be equal to the molar mass of this substance, because we know that 1 mole of methane will have 16.0 grams. That's the same substance we were just working with. So this time I had grams of methane in my numerator to begin with, so now I'm going to want grams of methane in my denominator, and the 1 mole of methane will go in the numerator. Okay, so we know this is an arrow. It's a little bit crunching on my number here, but This time it's different, right? Because the previous problem, the 16 grams was in the numerator, but that's because we started with moles. Here we're starting with grams, so that means this fraction is going to have to have been flipped. Okay, but still, we are still using molar mass as our conversion fraction we are still using the molar mass of methane as our conversion fraction. It's just flipped, depending on whether we're starting with moles or starting with grams. Okay, so coming back to this problem, I see grams of CH4 in the numerator, and I see grams of CH4 in this denominator over here, so they're going to cancel. And now the math just becomes 136 times 1 divided by 16. So let's try that. 136 divided by 16, and I get 8.5. But I need to maintain 3 total sig figs. So 3 sig figs to finish. And the only unit that did not cancel is moles of CH4. Okay. All right, let's take a look at a new substance. Now we're looking at magnesium oxide. How many moles? How many moles? That's what we're trying to figure out. How many moles of magnesium oxide are present in this mass? 100.75 grams of magnesium oxide. Oh, so I'm going to put that there because that looks like it got chopped off. All right, so always start with your given quantity. My given quantity is 100.75 grams. Now, I'm going to start to suggest very enthusiastically that when you are doing molar problems and you are identifying a quantity, 100.75 grams of a substance, you should really start identifying that substance. So every number you write down, especially for this unit, give me the quantity, give me the unit, and give me the identity of the substance. Okay, so we start with our given quantity, right? And so that's our first fraction because it's over 1, right? So we're putting it in the numerator. Now, what we want to cancel is grams of magnesium oxide in our denominator, and we are trying to go to moles of magnesium oxide in our numerator. Okay, so to do this, 1 mole, we always want 1 next to the mole because they're always going to have some quantity within 1 mole. We have to do a little side problem, right? So we need to go figure out magnesium's mass and oxygen's mass. Oxygen is 16.0, magnesium is 24.3. So I'm going to do a little side calculation, 24.3, 16.0, right? And so this is going to come out to 40.3. So 40.3 grams of magnesium oxide is in 1 mole of magnesium oxide. I'm going to look for units to cancel. I see grams of magnesium oxide on the numerator and grams of magnesium oxide in the denominator. And now it just comes down to math in the calculator. 100.75 times 1 divided by 40.3. I had 5 sig figs to start. So I am going to need 5 sig figs to end. I'm not going to let this affect my significant figures. So I am going to have to add some zeros. 2.5000. That's a lot, but there it is. And the only unit that did not cancel is moles of MgO. Okay, notice every number I'm writing down has a number, it has a unit, and it has an identity. One last problem here as an example. Now I'm going to ask you to find how many grams of magnesium oxide are in 0.385 moles of magnesium oxide. Got chopped. It's a little confusing when the name gets split up like that. So where to start? Start with the given quantity. Our given quantity is 0.385 moles. And here I wrote out the word, that's okay, I guess, of MgO. Now, my conversion fraction, I want moles of MgO in my denominator, and I want grams of MgO in my numerator. Now, I've already done this calculation for molar mass, so I know that 1 mole is equal to 40.3 grams of magnesium oxide. I will see that moles of magnesium oxide will cancel. And now the math. Now it's 0.385 times 40.3. I had 3 sig figs to start. I want 3 sig figs to finish. So rounding this number, looks like it's going to be 15.5 grams of MgO. All right, so this completes our lesson about the mole and molar conversions, where you use the molar mass of a substance that we can figure out from the periodic table, and we can use that molar mass to help us convert a given quantity of moles into grams or a given quantity of grams into moles of that substance. All right, so we're going to get practiced on this, and I will see you back in the classroom.